Welcome back. In the past couple of videos, we talked about execution engines and how applications make use of them. And we saw that execution engines can work through Yarn, or some things like Spark might go directly to HDFS and use the data. And then there are execution engines that sit on top of Yarn, and then applications that sit on top of those execution engines. So there's multiple ways to use applications on Hadoop. So this brings up the question of resource management and how you schedule the available capacity on a Hadoop cluster. So in this video, we talk about resource management, the different kinds of scheduling algorithms, and the types of parameters that you can control and typically control in these environments. So what's the motivation for these schedulers? So as I mentioned in the previous slide, there are various execution options and engines and the way you access resources. So if you just let Hadoop schedule by the default mechanism, you could end up issues with scheduling, like an important job that needs dedicated resources might end up waiting a long time. It might impact job completion because you might run some resources out of memory, for example. It can affect performance because of the way resources are being shared. So it's important to try and schedule things in an efficient way. And you want to be able to control how many resources are used, how much of the resources are used between components. So in terms of scheduling on Hadoop, the default option is to do first in, first out. So you end up with a bunch of jobs in the queue that essentially flow through. So you could potentially have a very small job waiting a long time because there's a longer job ahead of it, even though there's a resource available. You could have other options for schedulers. So these are plugins that go into the Yarn framework. So you have fair share scheduling or capacity scheduling. So in fair share, what you do is you try to balance out the resource allocation across applications over time. And capacity schedulers, you can have a guaranteed capacity for each application or group. And there are safeguards to prevent a user or an application from taking down the whole cluster by running it out of resources. So let's look at some details. So capacity scheduler. So here, the primary mechanism of control is queues. Each queue is guaranteed a fraction of the resource capacity. You can set hard and soft limits on these. Like in this figure, you can see you have 4 queues with varying fractions of the resource capacity. And then, as you can see, in each queue, you can have different users limited. So you can have access control lists that let you restrict access to particular users. And you can also restrict users from looking at and changing other users' jobs. So you can also do resource limits. So summarizing what we saw on the slide before, we have queues and sub-queues are also possible. You can do a capacity guarantee, and there is an option to do elastic expansion if resources are available. You can use ACLs for security, as I mentioned. All of this can be done runtime, and also you can drain applications. What this means is if you have a bunch of applications running and you want to make a change, you could say no new applications will start, but the existing applications will run till they're finished, and then you can make the change. You can also do resource-based scheduling with limits on memory and CPU. The other option is to use a fair share scheduler, and this essentially balances out the resource allocation among the various applications over time. By default, the fair share is based on memory, but we can add CPUs as a resource. So an example here, so going from left to right, you're seeing essentially a timeline. So when you start off an application and there's nothing else running, that application can use 100% of the cluster. Say now you submit a second application. As tasks complete as part of the application 1, application 2 can pick up some of the resources. So the fair share scheduler will try to balance things out. So like in the third step here, you see, app 1 is now at 75%, app 2 is at 25%. Now you submit another application and the fair share scheduler will try to balance things out. And the idea is in the long run, you try to even out how many resources each application gets. So to summarize, essentially, it balances out resource allocation over time. You can organize these into queues and sub-queues also, and you can guarantee minimum shares. You can do limits per user or per application. You can also do priorities that are weighted among the apps, so not every app gets the same share, essentially. So to summarize what we learned, the default setup on Hadoop is to do FIFO, that's first in, first out. But we have the fair share and capacity schedulers. As we saw, you can restrict based on queues and sub-queues. You can do user and app-based limits. You can do resource limits. Typically, that's memory, but you can add in CPUs. And I also want to add that in addition to this, if you have a commercial Hadoop vendor, you might have additional mechanisms that let you allocate resources among things beyond yarn. So you could have containers for how much yarn gets and how much something else, like maybe a Spark instance, will get. So there are other options, essentially.